we are ready to go with one of the ultimate and best kept secrets in math. And that is that logarithms are exponents. So you have to use your imagination here. You have to use your imagination. We're used to seeing things like x to the third plus 3x squared minus 2x plus 5. Okay, but that's from our seat. We're on the same level as the base is here. The base here is x, the base here is x, but there's a 3 in front of it. The base here is x, there's a minus 2 in front of it, and then there's a plus 5 out here, which is really 5x to the 0. Okay, which is why it's called a 0 degree. Anything raised to the 0 power is 1, so that's 5 times 1, which is 5. Everything is x to a power. Now, we're on the same level with the base. But what if somebody put you up a level so that everything up there, every person up there is an exponent? How would life be different? That's what you get to learn by dealing with logarithms. Because what you do when you're working with a logarithm is you are up one level from the rest of humanity and all the bases. You are up one level with the exponents. Kind of like with the angels or something like that. You're just not down here anymore.
Okay.
That's weird, and it'll take years to get it, probably. Hey, no fighting. No fighting. Excuse me, time out. Okay. Yes, these furry people do not always get along, and they do keep me entertained. George knows he gets kicked out when there's a fight, so he's pretty good.
Oh.
Because he doesn't really live here.
Oh.
Yeah, he belongs to somebody else, and he just comes by for Snuggie.
Oh.
Yeah. I think when his mom, his person, is working, he comes here. Because I have a cat door, he can just come in and out.
Oh.
Anyway, back to math. Yeah. All right. So, we're going to review the math real briefly, the math of exponents, because it's relevant. We're going to be living by those rules as we become logarithms or are up on the logarithm level. So here we go. X to the third times x to the 2, you recall, is x to the 3 plus 2, which is x to the 5. This is called the product rule of exponents. Okay, and I'm going to do the rest of them neater, and then I'll probably do it over again. Not now, but after. And then you've got the power rule of exponents. Let's start out here, the power rule.
I know what I'm putting on my flashcards.
Good for you. So x to the 3 to the 2 is x to the 3 times 2, which is x to the 6. That rule, the product rule and the power rule of exponents, students always find confusing. Always. Now, there's the quotient rule of exponents. And here, if we have x to the 5th power divided by x to the 3rd power, that gives us x to the 5 minus 3, which is x to the 2. This is called the quotient rule of exponents. And we've talked about this before and we've used them before, but now it's really important to keep this stuff in mind. There's also the 0 rule. Of exponents. Namely, that any number raised to the 0 power is 1. And then there's a rule that doesn't have a name.
Oh.
So let's call it the rule of 1. This is me naming it.
Okay.
But it sounds something like something from Game of Thrones or something. The rule of ones. I'm just about ready to start reading those books. I saw the television series. Maybe I should watch it again. The rule of ones. Here it is. 1. Raised to any power. Is 1. Positive 1 raised to any power is 1. Now I know there are others, but I can't think of them right offhand.
Uh-oh, that's okay.
Yeah. So anyway, all of these rules, the first 3, the product rule, x to the 3 times x to the 2, you add the exponents. Why do you add them? Because the bases are exactly the same. If they were different, you couldn't do this. Like if you add x to the 3 times y to the 2, x to the 3, y to the 2. There's nothing you could do with it. The bases have to be exactly the same, and I'm about to write that. But first I want to explain that with this one, though, it's not true because you're only dealing with one base. You're not dealing with multiple bases. But with this, it's true. If you had x to the 5 over y to the 3, that would just be x to the 5 over y to the 3, because the bases are different. There's nothing you can do.
Mm-hmm.
So we make kind of a general statement that these are the rules of like bases. Even though this one only has one base. And I guess we could call this the rule of base 1, couldn't we? That would be a little fancier. Rule of base 1. Ooh, that makes me feel like I'm a creator of something. All right, now the whole reason I brought this up is the following. Ooh, got a lot of room. Let me draw a line here. And I'm going to write the power rule, the product rule of exponents here. Gonna write it again. You'll see why. Now I'm going to write the product rule of logarithms. I think this is your first homework problem.
Oh, okay.
No. Okay. I always write the word log in script.
Uh-huh.
I'm not sure why I do that. I think because that could be a 1, right? If you're not familiar with the word logarithm, you could think it's 1 times logarithms. I mean, you wouldn't know. You wouldn't know in the beginning. So here's what I want to do. I want to write oops. I want to write oops. No, I don't. Log base 3 of 5 times 7 equals log base 3 of 5, here we go, plus log base 3 of 7. The bases, notice the bases are the same. The bases are the same. In both of these, we're dealing with like bases. And I'm going to go really slow, and it's not impossible that we're still going to be doing this tomorrow. Because if you don't understand this, you won't understand anything about logarithms.
Yeah.
The other side is true also. If we have log base 2 of 6. See, it doesn't matter. I'm just trying to find a convenient number. Plus log base 2 of 3. The bases are the same. The base is 2 for both of these. Like bases. Then that will equal log base 2 of 6 times 3, which is, of course, log base 2 of 18. And in the same way over here, this just occurred to me. On the exponent side, if you start out with x to the 5th, you can always break that down into x to the 3 plus 2, which is x to the 3 times x to the 2. So the other side of it is true also. When I first saw the rules of logarithms or the arithmetic of logarithms, I was not able to make any connection to exponents. And I think our calculus teacher just decided he wasn't going to tell us that we should know. I'd like to go back and clobber him. His name was Jones, Howard Jones.
Oh boy.
And he had been a NASA scientist. Then when he retired, he became a math professor.
Oh, wow.
And he was one mean SOB, let me tell you. But he was so mean that he was cute.
Oh.
He was an old guy, but he was cute. He was probably my age now.
Aw.
Okay. All right, that's our first rule. That's the product rule.
Woo.
Now, let's do the power rule. Okay, the power rule of exponents. And the power rule of logarithms. I'm just going to say logs because I'm running out of room. But I don't like that. No, no, no. One of the reasons I print almost all the time is that my script writing is so horrible. Okay, here we go. I think what we used up there was something like x to the 2 raised to the 3 over on the exponent side is x to the 2 times 3, which is x to the 6. So for the power rule, you multiply the exponents. For the product rule, you add the exponents. And that can be so confusing. Now, the other way around. The power rule of logs is this. I'm going to pick a base. It's not important. I'm going to let it be base 7.
Okay.
Log base 7. Okay.
Mm-hmm.
And we can even say x. Let's say x. Of x No, I'm not. I'm going to say, I'm going to use the same numbers. But I can't use base x. So log base 7 of 3 squared, how about that? Or, even better, how about log base 7 of 2 to the third?
Ooh.
The power rule for logs says this, and it's based on the exponent rule of the power rule of exponents. What the power rule of logs says is when you have that, because that's the base, as part of your argument that this number is raised to that number, what you're going to do is this. You're going to take the exponent and write it down in front and multiply that by log base 7 of 2. Now, if we put this in terms of x, we could have log base 7 of x cubed is 3 times log base 7 of x. And the other way is true also. You could start here and say x to the 6th equals x to the, I could say 1 times 6 or 2 times 3, either way, but let's stick with 2 times 3. And that would be x to the 2 raised to the 3, or quite frankly, you'd get the same answer if you said x to the 3 raised to the 2. That wouldn't matter. Well, over here, the other way is true also. If you have a number times a log of x, then you can rewrite that, and you will see when it's more convenient to do that. Log base 7 of x to the 3rd. That's because of calculators. I mean, it's more convenient when you're using a calculator to take this and write it this way.
Mm.
For all sorts of reasons you'll see. Now the quotient rule, let's do that. The quotient rule of exponents is, I think we said x to the 5 over x to the 2 is x to the 5 minus 2, which is x to the 3. The quotient rule of logs would say something like, change to a number. Give me a number.
7.
Oh, all right, well, all right, we'll keep it 7. It doesn't have to be, though. I'm just making that number up. You could choose a different number. It doesn't matter. Log base 7 of x over y equals log base 7 of x minus log base 7 of y. And the other way around. If you had log base 7, I don't know, let's make up numbers now, of 3 minus log base 7 of 2, don't for a minute think that would be 1, equals log base 7 of 3 over 2. So these rules go both ways. When you go from this to this, that's called expanding the logarithm. When you go from here to here, it's called contracting the logarithm. You don't have to know that, you don't have to use those words, but that is what it's called.
Okay. You said the 18 one is contracting, and then the other one is called what now?
I am out of room. Let me go down here.
Okay.
Okay, you're expanding the logarithm.
Mm-hmm.
You're not doing anything to the graph. It's not like transformations, but it's just a choice of words.
Right.
Expanding the logarithm. When you go from one term to two terms. So this would be log base 7 of a times b. That's one term.
Mm-hmm.
When you use the product rule to go from log base 7 of AB to log base 7 of A plus log base 7 of B. So you're just making it look bigger. That's why it's called expanding. And contracting the logarithm. If you go the other way, log base 7 of A plus log base 7 of B is log base 7 of AB, A times B. And the same is true for the quotient rule. You're expanding the logarithm. Notice how I keep using fewer and fewer words. Log base 7 of A minus log base 7 of B. No. Wrong way. I'm going from more to less. That's not expanding, that's contracting. Log base 7 of A over B equals log base 7 of A minus log base 7 of b. Okay, and then you're contracting the logarithm when you go the other way. Log base 7 of a minus log base 7 of b equals log base 7 of a over b. So that's always going to be true when you go from making something that's all scrunched together. When you spread it out, it's expanding. When you take it from its spread out version to its scrunched up version, here, like this. Nothing like toilet paper. When you take it from this way to this way, you're contracting.
Yes.
Now, when you take it from this way to this way,
it's expanding.
That's it. So you do the same thing with logarithms.
Ah.
And so you're going to have some homework like this.
Oh.
Now, there are other things to know.
Give me 1 second, Miss Barbara. Let me finish writing that down.
Sure thing.
Awesome. Okay.
All right. Now, the zero rule. The zero rule of exponents is that any number raised to the 0 power is 1. Now, there is a zero rule of logarithms. And here it is, and I actually have to stop and think. Yeah, okay, all right. Log. Base 7 of 1 equals 0.
Oh, okay.
It's also true, that's going to be true for any base. It's always, always, always going to be true that the log to any base of 1 equals 0.
So it can be log 3, log 2, and it's still going to be 0.
Uh-huh.
Base.
It can be log 85, log base 85 of 1 equals 0. Now there's something else that's always true. Log to any base in the universe. The argument of the function can never be negative or zero. Never negative or zero. So that has to do with the domain. The domain of a logarithm is always strictly greater than zero. That is, whoops, no, don't do that. We're working in the digital age. Don't have to mark through stuff. X is strictly greater than zero. It's never equal to, so you don't put that equals to bar underneath. So see, there are lots of individual things to remember. On the other hand, there's something very, very cool that's true for any base. I love it. If you come over here to the exponents, there is, let's see, exponents. The exponent 1, so 7 to the 1 power is 7. 3 to the 1 power is 3. 32 to the 1 power is 32. That's just the way 1 works. Well, it just so happens that it's true for any base that the log base b of b is 1. No, it's not. Is it? Yeah, it is. It is. It is. Because that's the exponent you use on the b. This is b to the 1 equals b. And since the logarithm is the exponent part, and the base goes down here, log b, so that base goes down there. The logarithm, the 1, goes over here. That's where the exponent goes. The only thing left is that, and that becomes the argument. So whenever that and that match each other in a logarithm, the answer is 1. So for instance, log base 7. Did I already write that? Log base 7 of 7 is 1. And log base e, we're going to be using e a lot. Log base e of e is 1. Except now, guess what? We talked about this yesterday, but now it's getting important. Log base E is not written that way. Log base E is written as Ln. So the Ln of E is 1. We're going to use this the very last day that we have new material. We are going to use this rule so many times because it's a great shortcut. Okay, now comes the most intense part.
Okay.
Is you have to be able to do this backwards and forwards. And it's, okay, wait a second here. Correct. That's where this goes. 9.5, no, it'll shout. It'll say, oh, no, you can't use that. Fine. There. I get yelled at by computers a lot.
Oh, no.
You know, it's not fair. I tell them, look, I'm not perfect, but most of the time I'm a pretty nice person. And you yell at me all the time. Do you know what it told me? It said, well, get smarter and I won't yell at you. That's the way computers are.
Aww.
I know, they're rude. They don't care. Ugh. This is what I'm drinking, coffee. I haven't gotten my new coffee mug yet.
Aww.
I'll know it when I see it, right?
Yeah.
And then I'll get 3 of them. All right, now, homework. Nope. Most important thing.
Yes.
Okay, here we have y equals 7 to the x. This is an exponential function. Let me say f of x, that'll make it official. Must be official. We're going to go through the steps to find the inverse function of the exponential function, and it is the logarithm function. So step 1 is y, change the f of x to y. Step 2, switch the x and the y. Step 3, solve for y. Step 3 is what stopped mathematicians from being able to calculate the logarithm, because who would have thought of logarithm? It had to be, for hundreds and hundreds of years, they tried to find what you write here, and they couldn't do it. The most brilliant people in the world. Finally, the logarithm was found by accident. I think I said that.
Yes.
And so now we can do this. Watch carefully and remember that it's that is the logarithm, okay? The logarithm equals the exponent. Y equals. And here's what we do with the rest of it. log. Now the base of this is 7.
Yes.
7 is the base, y is the exponent. 7 goes down here. And x goes here. So the inverse function of x, in other words, the inverse of f of x, is going to be log base 7 of x. And they are inverses of each other. So something we have to do is be able to take something like x equals trying to make these up is often a disaster. X equals 3 to the 13th power. Now that could well make your calculator go crazy. Okay, so rather than, pardon me?
I'm like, oh, that could make our calculator go crazy.
Yeah, make it jump to scientific. Oh, I know something that will make it jump to scientific notation. Let's see. 3 raised to the 13th power. Let's see if that will.
Nope.
No, no. How about 25 raised to the 13th power?
Ooh, yeah.
Yep, it does. See the E? That means it is. Okay, that'll go crazy. We got it now. So forget this. X, the base is going to be 25.
Okay.
Because, you know, you've got to know scientific notation to get that answer. What am I doing? I don't know, I'm so excited. All right. What we need to do is do this. Say, no, I don't want scientific notation. So, if you know that 13, the exponent, is going to equal log base 25 of x, then you can still work with it. Or at least you can make MyMathLab happy and say that the two are equivalent. Because they are. The reason we can't get an understandable answer, an immediately understandable answer from this, is that one of the basic problems of exponential functions is that they grow too large to measure. One of the reasons we use logarithms for those scales like the earthquake scale, the hurricane scale, the tornado scale, is that it's easier to measure. The graph of it rises much more slowly than the exponential that goes like that, gets so big very quickly you cannot measure it. 25 is not a big number. 13 is not a big number. But you put them together like this, and they're not really measurable anymore. But with this, yes, you can. The homework. So that's what I want. What I want is the homework. Yeah, here's the homework. Okay. Move that over so I have more room to write. Okay, here's number one. Number one, of course, you're going to have a video with this, but log base 9 Now, notice the instructions. Express as a sum of logarithms. With this, the instructions are just as important as the problem itself. They're not using expand right now. They're just saying express as a sum of logarithms. Okay, so the original problem has nothing to do with addition, it's multiplication. But when we expand this, we get a sum of logarithms because we'll have two things being added. We'll have log base 9 of 11 plus log base 9 of 25. Okay, so that's using the product rule. We could even say that. Now, the instructions for number 2, which I'm about to write big enough for both of us to see, says express as a single logarithm. So what you're given is log base t of 60 plus log base t of 14. And that is the other side of the product rule. Log base t of 60 times 14, and that will be log base t log base t of whatever 60 times 14 is. $840, I think.
60 times 14, 840. Yeah.
Yay! Okay, so that would be your answer. Here we had a product of two logarithms that do have the same base. All we had to do was put them, well, we didn't, we had a sum, didn't we? We had a sum of two logarithms, but that the product rule permits us to put them together as one.
So we compressed it.
Yeah, we compressed it, you betcha. Okay, let's check out number 3. Oh dear, number 3, but it's not as bad as you might think. Number 3, express as a product. That means as two things multiplied. Express as a product.
That means two things multiply?
Uh-huh. And here is the problem we're being given. Log base capital M, and when they use a capital, we have to use a capital, even if we don't want to. Okay, log base M of t to the -3. And that is the power rule. You take the exponent down in front. What I imagine is this is a girl with a pom-pom. And she's in the stands. And her pom-pom is stopping the people in back from being able to see the game. So they're saying, hey, down in front. That's called a mnemonic device, and it helps your memory if you make up little stories about things. There. And that's all you have to do. -3 is being multiplied by log base M of t.
Oh, okay. So we just take the exponent and put it up front.
Uh-huh. Down in front. Now, number 4. Number 4, we're going to be using the quotient rule. Log base R of capital G over 2. And the instructions say express as a difference of logarithms. In math, the word difference means subtract. So this says express, should have put it at the top, but I didn't. Express as a difference of logarithms. Difference, yeah, let's put that in parentheses underneath it or wherever. It means subtraction.
Mm-hmm.
All right, so that's going to be log base R of the top, the numerator, minus log base R of the denominator. And we're done. That's a difference of logarithms.
Hmm.
And this one also has a video with it. So far, the first 4 have videos. And so does the 5th one. The 5th one is totally mean.
Scary.
Scary. However, we should give it a try.
Yes.
It uses all the rules together. Okay. So, where did you go? There. All right, I better write this down quickly. What does it say? Express as a sum or difference of logarithms without exponents.
Ooh,
Okay.
without exponents.
So express as a sum, two things added, or difference, two things subtracted, of logarithms without exponents. All right, let me write down this and then I'll continue the sentence out there.
You're good.
Oh, wait a minute, maybe I have some room here. Sum or difference of logarithms, I'm going to say logs, without exponents. Yeah, I think that's understandable. Okay, so log base B of the sixth root
Sixth root
of x to the 5 over y to the 6 times z to the 7. Oh my goodness. I have not worked this. This is the first time I've worked this because this talking to my phone doesn't help either. Have you noticed that? Actually, if you use one of those, you know, helpers, yeah, all I have to do is say shut it off and the phone shuts off. But yeah. Better not. All right. So I'm going to rewrite this first as log base B of x to the 5th. Ooh, yeah, that's a good way. Wait a minute. Boom, boom, boom. X to the 5th over y to the 6th, z to the 7th, to the 1/6 power. That's the same thing. The sixth root of anything is that thing to the 1/6 power. It can be written either way. Tell me when to go on.
Go on.
Okay, I'm going to spread this out now. No, maybe not. Okay. Equals. I'm going to, the very first thing I'm going to do, this is going to be like peeling the onion. The very first thing I'm going to do is take this 1/6 down in front. 1/6 log base B of x to the 5th over y to the 6th, c to the 7th. Now we'll continue over here. So 1/6 log base B of Yeah, all right, all right. Now, look at this. This is now a quotient. This is now, well, it's a fraction, but it's also a quotient, you know? I mean, it's something being divided by something. So we can write this as 1/6. I'm going to do something first. I'm going to rewrite it the way it was. X to the 5th over y to the 6th, z to the 7th, like that. Now I'm going to put brackets here temporarily. That'll be 1/6 bracket log base b of x to the 5th minus log base b of y to the 6th z to the 7th. Close brackets. Okay, that's what I've got so far. Log base b. But this looks a little bit too much like a fraction bar, so I'm going to rewrite the word log base b. Log base b. There, that's a little neater. Well, I need to be able to read it without messing up, especially since this would be hard for anybody because there's so many details. You get one little thing wrong and boom. Okay, so we have 1/6 bracket. The 5, see how we're going one step at a time. The 5 comes down in front like that. So 5 log base b of x. Minus. Now, log base b, so I'm going to put parentheses out here. Log base b of y to the, this is a product. So this is going to be log base b. Yeah, it is. Not the way I wrote it, it's not. Log base b of, okay. Of y to the 6th plus log base b of z to the 7th. I thought about putting parentheses around y to the 6th and z to the 7th, but I think it would have just complicated things with having parentheses and parentheses and all of that. So anyway, here we go. I'm going to have equals 1/6 bracket 5 log base b of x minus parentheses. The 6 is going to come down in front of the word log there. 6 log base b of y plus the 7 comes down in front of that log. 7 log base b of z bracket. Now, 1/6. Okay, come on. Not ready to stop yet. Almost done. Do you have to leave?
No, you're fine. Keep going.
When you do have to leave, let me know.
Okay.
We will continue this tomorrow very easily. I'm going to distribute that minus sign to here and to here. So I'll have minus 6 log base b of y minus, because minus times plus is minus, 7 times log base b of z, bracket. Now that is pretty darn beautiful, but they might want us to distribute in this 1/6. So we're going to do it. 5 times 1/6 is 5/6 log base b of x minus 1/6 times 6 is 6/6, which is 1, log base b of y minus 1/6 times 7 is 7/6 log base b of z. Ha! And that, we're not done because this 6/6 needs to be a 1. So one more step here to make it, to clean it up. 5/6 will end after this for today. Log base b of x minus, that's a 1. So log base b of y minus 7/6 log base b of z. And there we go. I'm going to save this. Okay, all it takes is one little bitty error to ruin the whole thing. You sure you have time? Please go ahead and leave if you have to. Okay. 5 divided by 6 key log, L-O-G. Now I use the subscript button down here for the base, which is B. Now I have to hit the right arrow key to come back up. Parentheses X. Ha! Well, fine. Oh no, oh no! Oh, all right. It thinks I was wrong. How horrible. Won't be the first time in my life. Okay, as I say, I've made plenty of mistakes in my life. Look at my ex-husband.
Oh no.
I didn't say that. No, I didn't say that. Log base b of y, that's easy enough. Log base b, back up, right arrow key, parentheses, y, plus,
minus 7 to the
minus, yeah, minus 7/6 right arrow key, log, subscript key, B, right arrow key to come back up, parentheses Z. Okay, gonna check answer. Beat, 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 beat. I'm stunned. All right. Because like I said, something like that, it just begs you to make one little error. My goodness. Whew. All right. We did the first 5. Tomorrow, we continue with number 6.
Do you want to do one more?
Do you have time?
Yeah, till 12.
All right.
10 minutes, yeah.
Well, what about eating? You need to eat.
Oh, I already ate. You're okay, Miss Barbara.
Okay, okay. You know, once you're a mother, you're always a mother. Oh, you've got to eat or you'll get malnourished. And with COVID-19 and all. I bet I sound like your mother. Or your grandmother.
My grandma for sure.
Your abuela. Log base 7 of 19 W.
Ooh, W, okay.
Equals log base 7 of 19. That's 19 times W. So this will be log base 7 of 19 plus log base 7 of W. And that's it. Want to see if it's right?
Sure.
That'll just take time. Log log subscript key 7. Right arrow key, back up. You got to remember to do all of this. Parentheses 19. Plus log base 7. Subscript. Right arrow key. Parentheses W.
Whoa.
Yay. All right, and that was the product rule. So let's write this down.
Okay.
Just to kind of keep track of them. I have your practice final exam up.
Oh, you do?
Yes,
Ooh,
just so
okay.
you know.